Hello students, welcome to EPG Pathshala. I am Dr. Ashish Sehajpal, Assistant Professor from University Business School, Punjab University Regional Center, Ludhiana. Today we are going to discuss about the module System Approach to Problem Solving under the paper Management Information System. After completing this module, the students will be able to understand the concept of a system approach to problem solving, understand how system approach can be applied to information systems, and lastly, to understand the concept of system approach with practical examples. Today's problems cannot be solved by the same level of thinking that once created them, in words of Albert Einstein. The above, as stated by one of the greatest thinkers of our century, had made the strongest case for an approach that needs us to do more than trying to address the whole by merely stimulating its part. Prima facie, it is important to comprehend what exactly do we call a problem. A problem is decided by its purpose. In a situation, a person has a headache and desperately needs aspirin. However, he has no medicine at home nor a substitute. This creates a problem. But the case where a person is healthy and is not suffering from any headache and there is no medicine in the house, it doesn't create a problem. The term system denotes various characteristics, components, merits, and demerits of a particular subject that may be biologically or commercially. Every system has certain objectives to be achieved. To achieve this, it has certain elements like input, output, and processing devices. A system is engaged accordingly to certain rules, regulation, principles, and policies. Also, the arrangement depends upon some logic or objectives. The system approach to problem solving uses a system orientation to define problem and opportunity and then develop appropriate feasible solution in response. An organized, purposeful structure that consists of interrelated and interdependent elements, that is, components, entitles, factors, members, parts, etc. These elements continually influence one another, directly or indirectly, to maintain their activity and the existence of the system in order to achieve the goal of the system. In the simplest term, a system is composed of parts that be related directly or indirectly, else there shall be two or more distinct systems. A system has a definite boundary. It can be nested inside another system or shall overlap with another system. It is bounded in space and time. An important characteristic of a system is that they may be broken down in subsystems. The way in which this breaking down is done in any particular situation will depend on the nature of the system being studied and therefore on the extent to which detail is important. To decide on the amount of subsystem detail needed may require an analysis in depth of the system and its interaction. The sale function of a business can be viewed as a system. This can be inferred from the fact that is poor sale performance output caused by inadequate selling effort input, output of date sales procedure, that is the processing, incorrect sales information, the feedback, or the inadequate sales management, that is the control. Said figure, it depicts a system process. Now let us define system approach to problem solving. So we could have a scientific method approach and a system approach. Let us first try to understand the scientific method. The system approach is based on the established problem-solving methodology known as the scientific method. This scientific method consists of 5 steps, that is, to recognize phenomena in the real world, formulate a hypothesis about the cause or effects of the phenomena, test the hypothesis through experimentation, then to evaluate the results of the experiments, and finally draw a conclusion about the hypothesis. Whereas the system approach is a modification of the scientific method. It stresses a systematic approach of problem solving. Problems and opportunities are viewed in a system context. The system approach to the problem solving uses a systems orientation to define problems and opportunities and develop solutions. Studying a problem and formulating a solution involves the following interrelated activities. The very first is to recognize and define a problem or opportunity using system thinking. Develop and evaluate alternative system solutions, and then to select the system solution that best meets your requirements, to design and select system solution, and finally to implement and evaluate the success of design system. So let us now study these interrelated activities in detail one by one. Recognize and define a problem or opportunity using system thinking. Problems and opportunities are identified in the very first step. A problem can be defined as a basic condition that is causing undesirable results. An opportunity is a condition that presents the potential for desirable results. Symptoms must be separated from the problems. Symptoms are merely signals of an underlying cause or problem. The next, that is, develop and evaluate alternative system solution. System thinking is to find systems, subsystems, and components of system in any situation under consideration. This viewpoint ensures that important factors and their interrelationships are considered. The business organization or the business processes in which a problem or an opportunity arises could be viewed as a system of input, processing, output, feedback, and control components. There are usually several different ways to solve any problem or pursue any opportunity. It is imperative to make an assessment of the various advantages and disadvantages of several alternatives. In this stage, the analyst use creativity to come up with possible solution to the problem. Typically, in this stage, only the outline of the solution is generated rather than the actual solution. The next, that is, to select the system solution that best meets your requirement. So once alternative solution has been developed, they must be evaluated so that the best solution can be identified. The role of evaluation is to determine how well each alternative solution meets your business and personal requirement. These requirements are key characteristics and capabilities that you feel are necessary for your personal or business success. Thereafter, to design the selected system solution, once all alternative solution has been evaluated, you can be in the process of selecting the best solution. Alternative solutions can be compared to each other because they have been evaluated using the same criteria. So the next step of system approach involves implementation and evaluating the success of designed system. Once a solution is selected, it must be designed and implemented. It may be necessary to depend on other businesses and users, technical staff to help develop and design specification and an implementation plan. Typically, design specification might describe the detailed characteristics and capability of people, hardware, software, and data resources and information system activities needed by a few system. An implementation plan specify the resources, activities, and timing needed for proper implementation. This usually include type and sources of hardware and software, construction of physical facilities, hiring and training of personnel, startup and operating procedures, conversion procedures, and timetables. It is imperative to note when using the system approach, the steps can overlap each other. Activities required for problem solving can be used in more than one step of the process. The completion of activity is one step may extend into the performance of another. Sometimes you may have to cycle back to a previously completed step. Now let us try how to apply the system approach to information system. When the system approach is applied to the development of information system solution to business problems, it is called information systems development or application development. The system development life cycle, the concept is the application of the system approach to the solution of information system problems, which involves the system investigation. In this step, a business problem or opportunity is identified. Questions related to what causes a problem and what would be a feasible information system solution to the problem have to be answered. This step also includes the screening, selection, preliminary study of proposed information system solutions to the business problem. The next step is to conduct a feasibility study. The feasibility studies are primarily studies that investigate the information needed, objectives, constraint, resource requirements, costs, benefits, and feasibility of a proposed project. Usually, a formal feasibility report is given to management for approval before the system analysis stage can begin, which includes organizational feasibility, how well a proposed information system supports the objective of organization's strategic plan for information system. The second is the economic feasibility. The economic feasibility are expected cost savings, increased revenue, increased profit, a reduction in required investment, and other benefit exceeding the cost of developing and operating a proposed system. The third what we talk about is the technical feasibility, whether hardware is reliable and software capable of meeting the needs of proposed system. And lastly is the operational feasibility, the willingness and the ability of the management, employees, customers, and suppliers to operate, use, and support a proposed system. Next, what we undertake is a system analysis. System analysis is an in-depth study of end-user information needs which produces functional requirements that are used as the basis for the design of new information systems. System analysis involves a detailed study of the information needs of the organization, the activity, resources, and products of any present information system, and the information system capabilities required to meet the information needs of end user. Then we talk about the system design. So system design consists of design activity which produce system specification satisfying the functional requirement developed in the system analysis stage. These specifications are used as the basis for software development, hardware acquisition, system testing, and other activities of implementation stage. The system design stage should result in three major products. the user interface design, the data design, and the process design. The user interface design focuses on interaction between end user and the computer system and includes design for computer display screens, user computer dialogues, forms, and reports. On the other hand, the data design focuses on the logical structure of databases and files to be used by a proposed system. And the process design focuses on the design of the computer program and of procedures that need to be followed in the proposed system. The logical system design is the process of developing journal specification for how information system can meet end user requirement, while the physical system design involves the detailed design of user interface method to develop hardware, software, and personal specification for the new system. The physical design aspect must correspond with the specification derived from the logical design phase. So let us now focus on to the next step, that is system implementation. Once a proposed information system has been designed, it must be implemented. This involves hardware and software acquisition, software development, testing of programs and procedures, development of documentation, and education and training of end users and specialists who will operate the new system. Then the next steps comes in. What we talk about is the computer-aided system engineering. The traditional system development life cycle process is often inflexible, time-consuming, and expensive. Computer-aided system engineering or computer-aided software engineering, or what we call as CAS, has emerged to help with project management, interface design, database design, and software development. CAS involves using software packages called CAS tools to perform many of the activities of the system's development lifecycle. The CAS packages provides tools for the front end of the system development life cycle, planning, analysis, and design, as well as the backend, that is implementation and maintenance. Many packages now include a system repository component that expands the role of the data dictionary as a catalog of data definition. A system repository provides system analyst with computer-aided data description and other cataloging facilities, beginning with their system planning and system analysis activities and continued through the design, implementation, and maintenance of the system. Thus, the repository has become a database for all the details of a system generated with other system development tools. Then we'll be talking about the prototyping. Microcomputer, workstation, and a variety of case and other software packages allow the rapid development and testing of working models or prototypes of a new application in an interactive process involving both system analyst and the end users. Prototyping not only makes the development process faster, but it has opened up the application development process to the end user. Exemplifying the system approach. A systems approach requires seeing the whole picture and not just a fragment, understanding the broader context, appreciating interaction amongst level, and taking an interdisciplinary approach. A system approach highlights the importance of the circumstances or context in which an action is taken in order to understand its implementation and potential impact. For example, considering the case particular city, we can measure the total amount of fuel consumed in that city. that is becomes the input, and the total amount of pollution generated the output. Without knowing which person was responsible for which part of the pollution, this view consider the system as a black box, implies that it takes input and produce output without us being able to see what happens in between. In contrast, if we can see the system internal processes, we might call it a white box. However, the black box view may not be completely satisfying. Many processes in the body we do not know how they occur. Doctors may observe that if they give a patient a particular medicine, that is an input, the patient will react in a certain way, which becomes an output. That is by producing more sweat. However, in most cases, they have little idea about the particular mechanism which leads from the cause to the effect. Obviously, the medicine triggers a complex chain of interconnected reaction involving different organs and parts of the body. But the only thing that can be clearly established is the final result. So friends, let us take another example of system approach. ABC is the coach of an Indian cricket team. Assuming the objective that ABC has is to secure a win over the touring Australian cricket team. The coach uses a system approach to attain this objective. He started by gathering information about his own team. The system approach views a team as a system whose environment includes competitors, umpires, regulators, crowd, and media. His team, that is, the system itself, may be conceptualized as having two subsystems, that is, players and sporting staff for players. Each, each subsystem would have its own set of components, entities, like the players subsystem will have openers, middle order batsmen, fast bowlers, wicketkeeper, etc. The sporting staff subsystem would include the bowling coach, the batting coach, the physiotherapist, a psychologist, etc. All these entities would indeed have a bearing on the actual outcome of the game. Then, the next, what we talk about defining the problem, the coach tries to understand the past performance of his team and the other team in the competition. His objective is to defeat the competing team. He realizes that the problem he faces of losing the game, this is his main problem. Now we'll be looking upon collecting the data. The coach employs his sporting staff to gather data on the skills and physical condition of the players in the competing team by analyzing past performance data, viewing television footage of various games, making psychological profiles of each player. The sport staff comes up with the following observation. Both teams use an aggressive strategy during the period of power play. The game is being played in Mumbai. The crowd has come to watch the Indian team win. A lose here would cost the team in terms of morale. The umpires are neutral and are not intimidated by large crowd sport but are lenient towards sledging. Then is identifying the different alternatives. Based on collected data, the coach generates the following alternative strategies. Play upon the minds of the opening players of the competitor by highlighting their personal difference using sledging alone. Employ defensive tactics during power play when the openers are most aggressive and not using sledging. Keep close in the fielder who would sledge and employ the best attacking bowler of the Indian team during the power play. Then is evaluating alternatives. After having generated different alternatives, the coach has to select only one. The first alternative may lead to loss of concentration on the part of opener and result in breakthroughs. However, there is a chance that the interpersonal differences between the two openers may have already been resolved before they come to the field, and in such a case, their strategy will fail. The second strategy provides a safer option in the sense that it will neutralize the aggressive game of the opener, but there is limited chance of getting breakthrough. The third option of employing aggressive close-in fielders to play upon the internal personal differences of the openers, and at the same time employing the best bowler may lead to breakthrough and may also restrict the aggressive openers. Selecting the best alternative. The coach selects the third alternative as it provides him with the opportunity of neutralizing the aggressive playing strategy of the opener as well as increases the chances of getting breakthrough wickets. Implementing and monitoring. The coach communicates his strategy to his players and sport staff, instructs sport staff to organize mock session and take tests to be employed to make the strategy a success. The player and the sport staff performance is monitored by the coach on the regular basis to ensure that the strategy is employed perfectly. Applying system approach for problem solving. Partitioning the system into black boxes. The system is partitioned into black boxes. This refers to breaking down the system into granules, sets of black boxes. These black boxes need limited knowledge to be constructed. To construct a black box, one needs to know the input that goes into it, the output that comes of it, and its function. The knowledge of how the functionality is achieved is not required for constructing a black box. The second, organizing the black box into hierarchies. This is the second stage of the simplification process. In this stage, the black boxes constructed are organized into hierarchies so that the relationship amongst them is easily established. Once a hierarchy of black boxes is established, the system becomes easier to understand as the internal working of the system becomes clearer. So students, let's now summarize what we have learned in this module. Systems, processes, and structures are basic concept of reflecting on development and use of information systems. A system thinking view is about gaining understanding by looking at the relationship between things. It is based on an understanding that if one considers a system as a whole rather than focusing on its component parts, then there are properties which can be observed which cannot be found simply from properties of component parts. System approach starts with the situation, with its complexity and uncertainty, where an acknowledgement part of the problem is to establish and agree what the problem is, and where there will really be a single right resolution. The system approach demands that problem solving needs to be carried out on a more interdisciplinary basis, and that many firms and organizations needs to be organized in more integrated way than at present.